Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics in Oracle Cloud. Our today's session is the Building Gen AI Solutions on Oracle Cloud Infrastructure. So in this session, we'll cover various Gen AI services that OCI developers have at their fingertips today. So one more thing, we do have our Day One and Beyond series, but we also do have some of our other series as well, like hands-on, the slide that Joe was just sharing. So please feel free to explore those as well. And I'll pass it over to you, Joe.
Thank you, Olivia. So I'm Johan. I'm a data scientist here at Oracle, and I help Oracle Cloud users and customers ramp up their analytics, machine learning, et cetera, using AI and ML to solve business problems. And I'll let Brian also tell us about himself, and then we'll dive in.
Hey everyone, my name is Brian McDonald. I am a Master Principal Data and AI Solution Architect, and I've been with Oracle for coming up close on 30 years. And my sole role is to work with customers and help them solve business problems with all the wonderful OCI technology that we have.
Thank you, Brian. So today, Brian and I are going to walk you through your GenAI options across Oracle Cloud Infrastructure, OCI, also known as Oracle Cloud. Then we're going to dive into selected services. So I will speak about Select AI, which exists in the Oracle Autonomous Database. It allows you, the user, to auto-generate SQL, Oracle SQL from a submitted natural language request. I'll also talk about the GenAI services, how to use LLMs on demand in the Oracle Cloud, as well as how to encode your unstructured text data, make it machine readable, convert text into vectors, which will then be stored in the vector database, which Brian is going to speak to. And he's also going to tell us how these GenAI services can be pipelined into a RAG solution or RAG agent. So he'll explain what RAG means shortly. But first, I'm going to talk about your GenAI options across OCI. Before I dive in, though, I thought I'd just very briefly explain what is AI, what is it good for, and the answer usually depends on who you ask. I work for Oracle. It's about using business data and algorithms to solve business problems. So AI is really very well suited for automating the repetitive, clerical work, manufacturing, using algorithms and data to perform the routine decisioning, which will allow your bandwidth limited people in your firm to spend more time, devote more time to more interesting, creative, and impactful work. And then there's a long list of other verticals and use cases where AI is applicable. And just a short list here is autonomous driving, which means AI for real-time decisioning on sensor data, using AI to personalize your sales, generate tailored recommendations to your customers, your shoppers, the people who are viewing your streaming content. AI can be used in healthcare to diagnose diseases, manage the billing, finance, manufacturing, the list goes on. One question you all might have is, what's the distinction between machine learning, artificial intelligence, and generative AI? Very, very briefly, machine learning has been around for decades. These are algorithms that are trained to use known facts to forecast or predict a single unknown quantity. And the two most widely used machine learning algorithms are regression, for instance, use today's business data to forecast tomorrow's sales, et cetera. Classifier, you can train a classifier to segment your customers, use demographic data to figure out, should you be, what should be pitching to this customer versus that customer. Machine learning has lower hardware requirements. These are smaller algorithms that often are trained and deployed on CPU hardware, whereas when you bump up to more sophisticated algorithms like AI, there we're talking about using bigger algorithms that require more memory, and they're often trained on larger volumes of data. AI algorithms are typically neural networks, and they're very well suited for fuzzier tasks that require a judgment call. Very often AI models are trained on decisions made by people. Simple examples are using AI to do translation. If you want to translate a blob of text from one language to another, there are many ways to do that translation, but you really want an algorithm, if you want to automate that, an algorithm to choose the best, if not the better options for that translation. Object recognition, voice assistants. When a person is speaking to their voice assistant, there's an algorithm there listening, trying to figure out what the request is, and then figure out how to deliver that request. Typically, AIs, these algorithms, they've also been around for a while. Some are trained on, deployed on CPUs, others on GPU shapes. And the main point, as you bump up in more sophisticated hardware from CPU to GPU, that requires higher skill level on the part of the developer, as well as additional cost, because GPUs are often quite a bit more expensive than the equivalent CPU shapes. Brian and I are going to talk about GenAI today, generative AI. So these are also neural networks, but they're trained to generate content. So the bulk of today's session will be about using GenAI to auto-generate text content at scale. This could be marketing materials, news articles, news summaries, issue summaries, summaries of customer complaints. If you produce a lot of products, your product specifications are evolving very rapidly, and you can auto-generate all that text-based content. And that's what Brian and I will speak about today, but you have other options as well. There's GenAI for generating images, video, audio, et cetera. So the list is growing every day. And typically these algorithms, they require large volumes of training data, and often they're trained and deployed using GPU hardware. And because these models are trained on, well, in the Oracle universe, they're trained on business data. Businesses are evolving over time. The business data is evolving over time. And as soon as you train and deploy that model, it is suddenly going stale over time as your business evolves. So the best way to keep your models up to date, whether it's machine learning or AI, is to do this in the Oracle Cloud using what we sometimes call the AI ML stack. Other times we call this our cloud data platform. In the past, it was our data lake. It's really the place in the Oracle Cloud where you store your data, use infrastructure to preserve that data, provide the hardware, the memory, the CPUs, the GPUs, the file storage, the high-speed networking to manage all that. So your data is flowing through that infrastructure. But you also have cloud services that help manage those data flows to ingest your data, store your data, curate your data, ETL your data, make your data visible to users who often are interacting with that structured data via Oracle databases. And there's a few highlighted here. There's Autonomous Database, HeatWave Database, there's OpenSearch for storing your documents. And all these tools have GenAI either there today or it's pending. So GenAI options are showing up in these OCI services. And today I'm going to talk about Select AI in the Autonomous Database. And I'm also going to talk about the GenAI services that exist in this upper layer up here, the encoding and the LLMs that are at your fingertips today. And that will then naturally segue into Brian's RAG discussion. RAG is short for Retrieval Augmented Generation, and he's going to go into greater detail about that. But the first thing I'm going to do is show you your GenAI options in the Oracle Cloud. The main message I want this audience to get from this webinar is you have a spectrum of options, and they start from the fast to deploy, easy to manage, easy to use. I say easier in a relative sense. So we'll talk about the Select AI service in the Oracle Autonomous Database today. What that enables is your database user can now quiz that data using natural language, human conversational language. There's an LLM there, a large language model that will recast that user's request into SQL. So it's auto-coding SQL for you. The SQL will run in the database, and the user will see the results in a front-end app. The next step up in terms of complexity, skill level required, development cost, infrastructure cost would be the GenAI services. So we're still way over here on the left end. So it's easy to easier, lower cost, faster to deploy, faster to maintain. The GenAI services, these are pre-built LLMs and encoders that are on demand. They're essentially models whose endpoint is waiting to be called. So you, the cloud developer, if you want to embed LLMs, text generated by LLMs, or if you want to encode your unstructured text, you would bake these AI services into your data handling pipeline. So it's low code, API driven. So we're still on the fast to deploy, easy to deploy, relatively lower cost. The next step up is what Brian is going to speak to, Retrieval Augmented Generation. So when I pass the mic to him later on, he'll explain what that really means. What we're not going to talk about today, but I want this audience to know we have these additional options at your fingertips today, is if you want to, for instance, import an open source large language model into Oracle Cloud and retrain that model, fine tune it on your proprietary data in a safe, secure, private way. It's also very possible here using our data science service. And specifically, I would call out our quick actions, which these are easy to use recipes that allow you to do that very rapidly. At the far end of the right side of the spectrum is train and deploy your LLMs. There you own the process from beginning to end. So there you're training your custom LLM with your high-skilled developers on GPU shapes. These could be single GPU shapes or a cluster of GPU shapes, such as available in our OCI supercluster offering. So the main message here, the short summary is, you have a suite of options for a suite of use cases: low skill, fast to deploy, others that require high skilled developers, bigger dollars because we're training and deploying LLMs on more expensive hardware. So those are best suited for those high dollar, big impact use cases. But again, the short story is whatever you want to do can be done today, GenAI wise in OCI. Next, I'm gonna show a demo of Select AI and go into detail. So I'm going to show one more slide about Select AI. Let me get that going, and then we'll pivot to a demo. So Select AI is a service that exists in the autonomous database today. And this is the simple button, easy button, relatively speaking. It's there at your fingertips today. It requires a very modest amount of configuration to turn on. And what it enables is it allows your users, who may not be SQL developer experts, but they can converse with their database data by asking questions of the service, which gets communicated. The question gets communicated to the Select AI service, which is functionality within a database. The database gathers that request, forwards some schema information to an LLM that is external to the database. That LLM could be hosted inside OCI. It could be external to OCI. It could be a custom LLM that you fine tune, you tailor to your private personal business data. So all the possibilities exist. The LLM is going to receive the incoming schema, the incoming request, recast that request as legit Oracle SQL that gets communicated back to the database. It executes in the database, and then the user sees the results in line either as a report or a chart. So that's the Select AI pipeline. So enough talking about the tool. Let's show off a demo of the tool. I'm going to show everybody the front end. So Select AI allows the user to ask questions of the database without actually composing SQL. So typically the user will log into a front end, and here I'm logging into Apex, which is our low-code application development tool. It's pre-connected to the Oracle Autonomous Database in the Oracle Cloud. I've already loaded in some EBS data, e-business suite data, about manufacturing projects that are being completed over time, scrap is being generated, et cetera. So the database is preloaded, and you can imagine there are business users who want to quiz that data without actually having to write SQL. So this is Select AI is the service in the autonomous database that allows those users who might not know any SQL, but who want to ask questions of the data. Or you can imagine there's a busy engineer or a manager who also wants to quickly ask questions about the state of the business, but without either having to spend hours writing and testing and debugging a complex SQL query or chasing down a database admin to compose that query for themselves. So this person is going to merely log into a front end. In this example, it's an Apex app called ChatGPT. We're going to select a setting or so. That one looks fine. And we're going to ask questions in this box here. And we want those questions to be recast by an LLM as SQL. As SQL get generated in the database will respond with query results, and they'll be shown in line in this app. So I've queued up a bunch of questions in advance. So the first question I'm going to ask is, you show me 5 random records about the works in progress table, the WIP table. In fact, I'll just speak it to this console here. Show me 5 random records from the WIP table. So there's my request. Press the play button. The word console should not have been included there, but let's see what happens. What's nice about Select AI is it's pretty forgiving when you inadvertently make errors in your request, typos, et cetera. The LLM usually understands what your intent was, and it's essentially taking your request plus schema information. So Select AI knows about what tables are relevant to me. That schema information, table names, column names, column types gets communicated to the LLM. The LLM recasts that request as legit Oracle SQL. So here I've clicked another button to get the console to show me what SQL query was generated by Select AI. And this is in fact the correct SQL query. Pull 5 random records from the work in progress table, and voila, we see the results in line. So that was a simple example of Select AI. Let's ask a more challenging question. So you notice this data set is around projects are starting, they're completing, they're generating quantities. Sometimes they're generating scrap materials. There's a net quantity. It's all timestamped. So this is the transactional data that the Select AI user, probably want to do aggregations across. Let's find a nice query that illustrates a group by count. So here the question is, how many records in that table are associated with each organization? So different organizations in this EBS data, they're creating products. Let's just count how many records. This is a very simple group by count ask. And let's see if Select AI can understand the question, figure out which tables to query from, produce the right SQL query, and then get it running in the database. That looks correct. And if you want to spot check your work, just ask the service to show you what query was generated. And it is, in fact, the work in progress table. We're doing a group by, and an order by, and a count. So that looks reasonable. Let's ask a more complex question. Here's my cheat sheet. So let's compute monthly sums of products or a product that's being generated. Let's also track how much quantity is being scrapped. Since we're doing this monthly, that's another group by sum operation. In some months, there's going to be 0 scraps. So let's do a null replacement. Let's append a filter. Let's do it for years 2003 through 2005 only. So now we're going to get 2 columns, every month, how much was produced, how much was scrapped. And then for grins, let's see how efficient our business is. Let's compute the scrap fraction. So let's generate these 2 columns and then compute the ratio to get the scrap fraction. So let's see if Select AI can manage that. So that's a lot of steps all in one ask. And we're just going to copy and paste that human-generated natural language request into the front end. APEC is going to gather that up, communicate schema information to the LLM. The LLM is going to look at the ask, figure out which table's that to do those group by aggregations from. Null replacements, everything looks legit here. And if we wish to spot check our work, again, we're pulling from the discrete jobs table. There's that filter I mentioned. It's a group by order by count operation, or I think it's a group by order by sum operation. And oh, by the way, let's do a derived result as well. Let's compute the ratio of those 2 quantities. So this all looks very legit. So this is Select AI. This is what this end, as well as the front end that the user will interact with. So that was Select AI, which is the relatively easy way forward to embed GenAI. Let GenAI auto-generate SQL for your non-SQL centric users. So now I'm going to pivot to the GenAI service, which is the next level up in terms of sophistication, complexity. These are pre-built LLMs that are hosted in the Oracle Cloud. There's a handful of LLMs that will, auto-generate text for you at scale. There's also an encoder there, which will convert your unstructured text into machine-readable vectors. These are low-code services. They're API-driven, and they're really meant for your cloud developers, your data engineers to inject the Gen AI into their data handling pipelines and applications. And the 2 we're going to talk about here, LLMs and encoders, are going to segue nicely into Brian's discussion of RAG. So the LLMs that are available today in OCI, the bulk of them are provided by a partner co here. And this is the functionality they provide. But there's also a growing short list of open source LLMs that are popping up in there. So there's one today produced by Meta. It's called Llama 2. Llama 3 is pending, and I believe that list is going to grow. But the main point is these GenAI services, they're pre-trained, they're hosted in OCI, so they're visible, within your cloud tenancy, very private. So you don't have proprietary data flowing outside of the cloud into somebody else's, a third-party LLM. It's all internal to your private cloud tenancy. And these LLMs and encoders are readily embedded into your data handling pipelines. So the video walkthrough I'm going to show shortly is going to speak about using the generate and the embed functionality that comes with the GenAI service. Hey folks, I'm going to show off the GenAI services in OCI. So I've already logged into OCI. I'm doing the various flavors of the GenAI services, chat generation, summation, embedding. We'll just talk about two of these. The main point is that these are pre-trained AI models that are hosted by Oracle. They exist in OCI. They're available for your services to reach out to. And typically, one is writing code or developing an app that calls the model's endpoint. So here, let's walk through just the generation of content. It's not meant to compete with ChatGPT. This is really a private internal service that is meant for enterprise that want to auto-generate content at scale. And this console merely illustrates how your developers would interact with that service. And what's nice about it is this is a low-code service. So it's zero code to trigger the model, but you're writing external code or developing point-and-click apps that call the model endpoint. They feed a JSON string in, and then of input data, and then a JSON blob comes out, which provides the generated text. So in the console, you can select your various models. We're going to play with the Llama 2 model. So this is an open source model, so I have to click an agreement the first time I use it. Let's just auto-generate some content. So here's the ask. This is what we are asking the model to do. We click the generate button, and we'll see the generated text below. So I'm a corporate vice president. Please generate an email, blah, blah, blah. And that email is auto-generated down here. And note that we can tweak parameters over here. We can change the temperature, how random or how not random we wish to play with. What's the number of tokens going in or out, et cetera, and regenerate the model. This point and click tool is really not going to be used by your users because there's no one would really do this in their day-to-day. Instead, it's the cloud developers who want to see how to call that model. So what's nice about this console, there's the view code button, and it'll auto-generate the boilerplate code that calls the model for you, Java, Python, et cetera. I'm a Pythonista, so this is the code I would copy and paste into my Jupyter notebook. I just copy it. I might want to tweak a few parameters here. I might want to tailor my OCID, which tells the endpoint where in the Oracle Cloud we're doing all this. Configurations are managed via this this boilerplate code. But here's the ask, and the result is generated in this object right here. So it's pretty straightforward to do. Copy paste the code and run at your end. And the main point is you don't have to read the manual. I've never once read the GenAI service manual to call this. I mostly just play with the console and wrapping up and then press the view code button. That's for auto-generating text. But the other popular subservice here that one is interested in is the embedding service. So this is the AI model that will convert text into vectors. And the reason we want to do this is it makes your unstructured text converts into structured vectors, which are just lists of numbers. You can store them in a database, like a vector database, and then you can do similarity searches. And that, in fact, is a key ingredient of the RAG pipeline. So again, we're going to pick a model. We're going to choose some example text to pre-populate. We're going to press the run button, and we're going to see the vectors generated down here. And you can export these vectors. If I click on the download, I think I'll see a pop-up over here of those vectors. So here's the text that was vectorized. Here's the vectors themselves. They're stored in a JSON file. And now I need to navigate back to my browser because really what I want to do is not play with this front end. I really want to view the code. So this is the code, being a Pythonista, this is the code that I would copy and paste into my Jupyter notebook. I might tailor a few things like here's the inputs, here's the credentials I'm using, here's the endpoint, and everything else is boilerplate. Copy into your notebook, run at your end, and you're good to go. Okay. So that was my fast introduction to the GenAI services. These are low-code, API-driven, tools for data handling pipelines. And now let's talk about another data handling pipeline, the RAG pipeline. So I'm going to pass the mic to Brian. He's going to tell us about Retrieval Augmented Generation, which is going to make heavy use of all the LLMs and encoders we just discussed.
So I'll talk now about the Retrieval Augmented Generation as Joe has introduced. Sometimes I'll call it RAG, depending on whether I want to use the full name or the shorter name. But as Joe kind of talked through the spectrum, we're really going to feed this specific area. And Retrieval Augmented Generation is really designed to extend that base LLM Joe just showed you, how you can interact with an LLM and answer questions. But what do you do when you have your own proprietary data? How do you instruct the LLM to reference this data, keep it up to date, and incorporate data that the LLM has not previously learned its information on? It wasn't generated based on that. So the way retrieval augmented generation works is you have your user here on the left-hand side, and you have your existing data sources. These can be your own customer databases, ERP, supply chain, HR applications, really any business system, whether the data is structured or unstructured, PDF, manuals, etc. And essentially what RAG does is it takes all this data and surrounds this large language model with all this information that you would incorporate on a regular basis. This could be daily, weekly, monthly, whatever makes sense to ensure that the questions that an end user is going to ask gets the most accurate and up-to-date answers. And this is really needed because there are some core challenges with LLMs. And Joe mentioned some of them, but particularly the hallucination. LLMs are really good at generating text, but sometimes they generate text that may not be completely factual. They make stuff up because that's what the model thinks will be right. So RAG gives you this mechanism to minimize or mitigate these hallucinations by grounding answers in the actual data that is relevant. Joe mentioned the frozen in time concept of LLMs. So RAG allows you to bring all your data up to date. You can update it consistently. They also don't have specific domain enterprise data. I'm going to show you an example of using RAG with a semi-manufacturing data. We have other customers who build RAG agents around metallurgical information. All of this stuff is what you as an enterprise, as a company that has specific information can feed into it. The one that I really love is LLMs tend to be black boxes. They give you an answer, but you don't really know how it gets there. I'll show you how RAG can provide citations of the actual documents that get you there. And most importantly, most organizations do not develop these foundational models. They're expensive, they take time. So RAG gives you the ability to extend them. So those are the key things of why you would want to use retrieval augmented generation. So let's take a look at how this all works. So we start off with this enterprise LLM, a foundational model, like Cohere, like Llama that Joe showed you how to interact with. But how do you incorporate all these documents? So typically you start off with a wealth of documents. Typically they're PDFs from my customers, and you would create this thing called a knowledge base. And the knowledge base is where you're going to store all these documents. But often you don't want to just take the documents as is. You want to do some processing on these documents. You want to do, split the text into smaller pieces. Maybe you want to do summarization. There's this process called chunking, which takes a large document and puts it up into smaller pieces. And this is necessary because if you wanted to generate a summarization of a very large document, that's really hard to do because there's lots of information. So by splitting it up into smaller pieces, you can encapsulate and understand those bits of data. But now that you've got these smaller pieces of data, you need to encode them. You need to take them from text into the embedding that Joe showed you. He showed you how to do this, and you would run it through this process, would embed it, and store it into a vector database. This is absolutely critical so you can store these data, these vectors, these encoded descriptions of the data in a place that you can retrieve. And once you do this, once you have your models and your vector database of your documents, you can now extend the LLM. So when a user comes and they ask their natural language query, they will do something called similarity search, which will say, how close to my question and the information I have is this document? And does it help with the LLM question, the prompt, the enhanced context that you will pass to the LLM? So all of this requires some technology, vector databases, embedding models. You need to have pipelines. You need to have other code to orchestrate all of this. And while it's not super challenging, there are lots of steps that you have to get right. So what we propose and what many other people are generating are these concepts called AI agents. And an AI agent is designed to address and orchestrate a specific interaction or a use case with the LLM so that the user doesn't have to do that. So in this very simple example, if you are going to interact with an LLM and say, book me a flight to Seattle, the agent along with the LLM will do all the work to actually book that flight and give you that message, your flight has been booked. So inside this agent plus LLM box, there's a couple of steps. So the agent will do the following steps. First is understand and interpret the prompt. So it'll understand, okay, they want to book a flight, so I need to create a reservation, and it's going to go to Seattle. Then there's another step that will determine the necessary actions. Oh, I've got to look at, itineraries, available seats, particular airlines, look at the flight pairs, retrieve any extra data as part of this process that's necessary, like, oh, it's Brian and I know his address and I have his customer or his credit card number. And if not, retrieve that and then actually execute those actions. Insert into the reservation system a reservation and get the confirmation code. So that's what an agent does. And Oracle in OCI is generating a lot of these agents. Joe talked briefly about an NL to SQL one that we're coming out with. And I'm going to talk about now our generative AI agent called the RAG agent. This is in limited availability right now. We have customers using it. It will be announced in a future date. But basically what our RAG agent does is it encapsulates and provides all the information we just described, that architecture, so that you don't have to do all that coding. So in the example here we see on this screen, you can come in through, say, a digital assistant like the Oracle Digital Assistant or a custom interface, ask questions, what conversations has Vision Corp related to analytics products. It will go against the reg agent, respond in a human-like manner, give you the right answer, give you some links, and allows for follow-up conversations. Rather than having a static image, let me toggle over to a quick little demo. So what this demonstration will show is our actual GenAI agent. Now, the first thing to be aware of is we just walk you straight through these particular tasks. So one is, first, you create your knowledge base, which is a very easy step, which says, point me at a set of documents in Oracle Object Storage, and it will handle all the rest, all that chunking, data pipeline, etc. And after you create that knowledge base and a refresh schedule, you will go on to create the agent. And the agent is the interface that points to a knowledge base that allows you to launch your chat session. So now we go into a sample chat interface, and I will pick my agent. This is my Ask Semi agent and an endpoint. And the interesting thing about this endpoint is this can be called by any type of code. So you can embed this into other applications or just run it as we see right here. And what I will now do is I will type in some questions. So I have PDFs that are very knowledgeable about semiconductor manufacturing. So I can ask a question of, do we have any research papers regarding fabrication errors? And you'll notice as this was running on the right-hand side, there's a log that will tell you when this request occurred, what the search string is, any sources that it retrieves, and the generated text, which you also see here, which is a very quick, high-level explanation that says, yes, we have relevant documents. It will show you an overview of them, and then it shows you the actual location of those documents. So I can, at any point, go look at them. Now, if I embedded this into a real application, I would just have the link here, click on it, and I can see that actual PDF document. Now, let's close the logs because we'll give ourselves a little more space. But what we can now do is then just have more conversations with the data. We've identified a document, so I can summarize this document, analyze the effect of UV Liga fabrication errors on microspring elastic coefficients. If anybody's in semiconductor, they probably know what that means. I don't. But it was very easy to summarize based on a document I didn't know existed just a moment ago. If you would have done this with the generic LLM, it would not retrieve this. I can also find out who the authors of this document are. So very quickly find the documents. I can find out the particular types of fabrication errors. And I gave it a little hint that said, show me this as a bulleted list. And we get that answers. As you know, typically I would read these documents and I might ask, what is this term in the document called SOLT? Never heard of it. Well, I can ask just very briefly, what is SOLT? And it will give you an answer. And I won't read through that answer. So that's one type. Another interesting way to use this is if you want to summarize documents. So here I'm summarizing the document as if I was a CEO. So in language that a CEO would understand. So you can see there is some technical jargon in here. It talks about, WR15 bands. It talks about a Savitsky-Golay filter. It uses MCK results, which I don't know, but if you're a CEO of a semiconductor company, you would probably know this. Or I can do a more simpler explanation, say, summarize this as if I was a fifth grader. And using that same PDF, interacting with the LLM, it will go ahead and summarize this data in a much more targeted manner. So that's the whole benefit of what we get with RAG extension of a large language model. Now we talked about the whole architecture of how to move things along for a RAG capability. Joe also showed the embedding capabilities. So, and I mentioned vectors in the database as a key component of building a RAG pipeline. So what Oracle has done in our 23 AI release is introduced a new data type called vectors. And what a vector is that embedding of some type of data into a series of numbers. And by making this a standard data type, just like any other data type, numbers, varchars, etc., we get tremendous benefits as part of the database. So I want to talk you through just a little bit about vectors, because some people may have heard them if you took a physics class somewhere along the line. Some mathematicians, talk about vectors. But let me talk about what we mean. So a vector represents the meaning, the content, the semantics inside some other type of data, whether it's an image or a document. This image over here looks like it has a mountain, a sun, and a person. So you need to convert all these data types, these non-structured data types, into numbers that can be interpreted. So a vector is just simply a sequence of numbers called dimensions used to capture the important features of the data. So the number of dimensions can vary. You can control those. But that's all a vector is. It's just taking a picture as an example or text and converting it into this vector. So to get a real specific example here, we've got a picture of a house. This is a house I like, and maybe I want to buy one. But in order to get this into the database, we do the embedding. And what this embedding will do is say, hey, what type of roof is it? This is a feature, a dimension I want to represent. I'm going to convert that to 33. There's some decorations here, some ornaments. Let's convert that to 42. There looks like it's a 2-story house. I'm going to represent that by 16, and it's primarily made of wood, so it's 21. So I am going to take this house, and here I have a 4-dimensional vector of these numbers. Now, the way to get these numbers is some complex ML algorithms that have been built out over the years. We're not going to get into that. That's what the embedding models do. But simply, we just took this house and created a vector. Now, if you have lots of pictures of houses, we can represent this here in a 2-dimensional space that's easier to view. And you can see here's one vector pointing to this house, another vector pointing here, and you can see the D1, D2 dimensions point in different ways. And this one, the house that I was looking at, is way over here. It's much more loaded on D2. So that's how things are stored, as these vectors, and we can now start comparing them. So we can see, based on these vectors, these two pictures of homes are very similar, but the one I like is not as similar to this one. So now that we know what vectors are, let's talk a little bit about how they're used. So vector searches are used to basically look through data, query them on image, documents, and it really works best when it's mixed with other business type of data. And that is why we've added AI vector search into the Oracle database, because our customers have loads of structured business data there. And now they can combine all that business data with the vector data to answer a wider range of questions. And most importantly, it eliminates the need to move data, to synchronize data, manage multiple products. Someone in the Q&A asked, or chat, asked about security. Well, now we don't have to worry about having a separate vector database and our standard business data database in Oracle, and worry about how do we manage users and security and synchronization. It's all in one database. So let's talk through an example of how this actually works. So let's just say I've built this wonderful app that allows me to search for homes. So I'm going to search for my favorite style home. I want a home as close as this as possible. So how do we do that? Well, we need to do two things. We need to find a good match based on the semantics of the picture that I just described, as well as data about myself. What city do I want to look in? What budget do I have? Are houses available? All of this becomes very easy with the Oracle Database 23 AI. So let's walk through kind of a code demo. So how do we do this? Well, we use the standard create table syntax. So we'll create a table, house for sale. We give the house an ID of a number. It's got a price. It's got a city. And here we're going to include the house photo as a blob. Oracle Database supports blob. It's a very robust feature. We'll add it in there. Now we've added a vector data type, which is the for sale house vector. So this is just converting this house through the embedding step that Joe showed and storing it in the database. So now you have a row that has the house ID, price, city, photo, and this vector. So to find houses, and say we wanted to find the top 10 houses that are most similar to what I like, just based on the appearance, I can just say select, and I'll select whatever columns I need from this table, from that house for sale, and I'm just going to simply order. I'm going to order by this new function called vector distance, which says look at the for sale house vector column and compare it to this input vector. And this input vector would be sent by the app of this picture. So it's really simple, because now all we're doing is we're just adding this order by the vector distance, which is how similar this picture is to every other picture of a house in the database. You don't need any knowledge of how to use a vector database or vector search. You don't need any AI expertise. Anybody who can write SQL can get access to this. And now when I want to extend it to include where the price is within my budget and the city is in the city that I prefer, you just add in these where predicates. The select part, the order by are exactly the same. So in just 6 lines of SQL, you get the ability to mix business data along with image data And it's all consistent, all secured in a single query that if you have visualization tools, you can embed that in a visualization tool, your BI tools, applications, just embed them there. It is very simple. So to summarize, from a vector capability and really tying everything together, what OCI is doing is providing the ability to leverage vector database, RAG, GenAI, select AI capabilities, all within a common platform where your data is in an Oracle database, as well as the generalized OCI services that Joe was showing to make it very easy to scale up and out, to index things, to partitioning, and make it very simple to consume. And that is the key to enabling your users to adopt all of this new generative AI capabilities. If it's too complex, people are not going to adopt it. So with that, if you want to learn more, we have a wide range of videos, demos, blogs, hands-on experiences that you can go and test. You'll all get a copy of this presentation so you can click on the links. Start with some of the explainer videos, then move to demos, and then the blogs have lots of hands-on on how to actually implement this stuff. There was a chat instance about the ChatDB capabilities that Joe showed. There's a link here for the live lab. And lastly, if you want to learn more about the other sessions, about all our guided learning capabilities and cloud capabilities, the ability to get a free tier and start testing a lot of the capabilities, you have all these links here. Of course, we have lots of cloud documentation and cloud adoption frameworks to get you started on your journey for generative AI, and always go to our core labs to learn more. So with that, I'll wrap up and see, do we have any questions for Joe or myself? And for our monitors, were there any questions on the chat? I can look and see what's there.
Brian, the only one I think you were starting to answer, Joe, it was a reference to the Chat DB UI. That's not a pre-built service within Apex, but that's a kind of a custom extension that you've created, right?
Correct. So the exact same ChatDB interface that Joe is showing is available as part of that live lab. So anybody who wants to take that can go to the live lab. You can actually run through the whole exercise and then just export the whole Apex app itself. And then you can import it into your own Oracle database. And then you'll just have to customize the connections to your particular database, your particular users, etc. So we make it very easy to migrate one application and leverage it. So you can be up and running, if you've done it before, probably 10, 15 minutes. I would plan an hour or so to export and get it up and then start interacting with your database.
This was super, Brian. Thank you for tag teaming this with me.
Right, if there are no further questions, awesome session. Thank you, Brian and Joe. Really appreciate your time and help with this session. Our next session will be disaster recovery in Oracle Cloud Infrastructure, or OCI, on August 20th at 10 a.m. Pacific. So we will cover the key concepts, techniques, and best practices for designing a highly available disaster recovery solution in OCI. So we hope to see you all then.